Hello. So in this video, let us discuss midpoint theorem, which is in class 9 or 10. So this activity gives us an easy way of understanding midpoint theorem. The theorem states that the line segment joining the midpoints of any two sides of a triangle is parallel to the third side and equal to half the length of the third side. Now, what does that mean? So, we will understand it using materials. But here we have two pieces of foam, one big quadrilateral and one triangle. And we have a metal plate. Now, these two pieces have magnets on them, so I can stick the quadrilateral on the metal frame, and then on one side of the quadrilateral I'm sticking the triangle in such a way that the one side of the triangle coincides with one side of the quadrilateral exactly to make a big triangle, triangle ABC. Now I have braille labels as well on the foam pieces. Now the first smaller triangle that we had is called APQ. Okay. Now P and Q are the midpoints of AB and AC respectively. So point P is here, point Q is there, and they are the midpoints. To see that they are the midpoints, I'm just bringing the triangle APQ on the quadrilateral such that AP overlaps on BP. When I overlap them, I can see that they are equal in length. AP is equal to BP. Similarly, I'm overlapping AQ on QC to see that AQ is equal to QC. That proves that Q and P are the midpoints of the sides AC and AB. Now, the line segment joining these two midpoints is the side PQ. So we have to prove that PQ is parallel to BC. That's one part. Let's prove that first. Suppose we for a moment we say that they are parallel. Okay. Then there is a transversal AC cutting them. The transversal AC gives rise to two corresponding angles, angle Q and angle C. Now, if PQ is parallel to BC, then angle Q should be equal to angle C because they are corresponding angles. In other words, if angle Q is equal to angle C, then we can say PQ is parallel to BC. Similarly, point P is the midpoint of AB. PQ and BC, these two are lines and they are cut by the transversal AB on the other side, giving rise to two angles, corresponding angles P and B. Now P and B, if in case they are equal, if the angles P and B are equal, then we can say PQ is parallel to BC. Let us see if angle P is same as angle B, angle Q is same as angle C. We'll have to take the small triangle, overlap it with the quadrilateral in such a way that angle Q falls on angle C, and check. Yes, when I check it, they are the same. Similarly, I am overlapping angle P on angle B, and I'm checking with my hands. Yes, they seem to be same. So we can say that angle P is same as angle B, angle Q is same as angle C. So if they are same, they are corresponding angles. If they are corresponding angles, only in case of parallel lines corresponding angles are equal. Therefore, PQ is parallel to BC. So we've proved the first part. Second part says PQ is half of BC. Now, in order to prove that, I'm again bringing the PQ, overlapping it with the side BC, starting from one side, and I'm seeing how long it is. It comes till about the midpoint. Now, to really see whether it is the correct midpoint, I'm just putting my finger there to start the next measurement, and I see that 2 times PQ is giving me the side BC. In other words, PQ, the length PQ, is half the length of BC, which is the second point. So both the points are proved. Isn't this easy?